In this video, I'm going to talk to you about representing forces with free body diagrams and vectors. So, just to recall, a vector is any quantity, any number that has both magnitude and direction. Magnitude and direction. Examples of vector quantities are acceleration, velocity, displacement, and now force. Now, one good way to represent vector quantities, which we've already used, is an arrow, sometimes called a vector. And the reason is that the length of the arrow can represent the magnitude, more magnitude, less magnitude, and the way it points represent the direction. So, for example, if these were acceleration vectors, this would represent less acceleration than this one would. All right, so how can we use the idea of the vector to make a picture of the forces, picture of the interactions with an object? Let's look at this object here. This is a water balloon sitting on a spring, which is sitting on some kind of platform. All right, I'm going to introduce you to what's called the free body diagram. I'm going to isolate, just for the sake of this diagram, the balloon from the rest of the object. I'm going to represent the balloon with a box. I could do it with any other shape, but a box is easy to make. And now what I want to do is represent all of the interactions, all the forces, with the balloon. Actually, let's list them first. Here are interactions with the balloon. And one thing that's interacting with the balloon is the spring. That's pretty obvious because they're touching there. A second thing that's interacting with the balloon is actually the earth. And we give a special name to that interaction. We call that gravity. But the object that's interacting with the balloon is the earth. All right, well now let's take these interactions and let's put them in a picture. Now what the earth does is pull down. That interaction causes the balloon to be pulled downward. And the spring has an interaction with the balloon, and the direction of that interaction on the balloon is upward. So we have two interactions with the balloon, and I've represented them here. So here, this is my free body diagram. But I want to be a little more specific. I want to label these interactions. So I'm going to label this force, earth, and balloon. That indicates the force, which is the interaction between the earth and the balloon. Over here, I'm going to label this force, spring, on balloon. Again, all this says is it's a force, and the subscripts there indicate the two objects that are interacting. In this case, the spring and the balloon. Now, right now, I've drawn these two vectors to be the same length. That would imply that that force is the same value as that force. But in fact, we have no idea about that because these are two different interactions, spring and balloon, earth and balloon. So the length in these pictures at the moment will not represent the sizes of the forces, but only the existence of those forces. Now in part 2, we'll look at drawing a free body diagram for the spring itself.